All right, let's go ahead and get started. Welcome everyone to the Noise and Environmental Considerations breakout session. My name is Ryan and I'm the noise specialist for this project. Alongside, I also have Cindy, who's handling all other environmental considerations involved with the project. I want to start by reminding you of a few housekeeping items before we get started. We strongly recommend you type your questions into the chat box. Make sure to keep your computers and microphones muted so we can clearly hear each other during the Q&A period. And feel free to come and go from this breakout room as you explore the other breakout rooms a part of today's public meeting. So we know you've logged into this breakout room to help understand the potential noise and environmental considerations of this project, and we're looking forward to answering any questions you might have. I'll start by quickly summarizing what we have done so far in the noise analysis. First, we have taken existing sound level measurements within the project area to quantify the existing sound levels from Randall Road. Second, we have reviewed all proposed improvement options and have given them a rating based on their potential impact to noise levels and other environmental effects in the area. Now, I'll briefly summarize what steps are yet to come from a noise perspective. In addition to existing measurements, a traffic noise model will be generated for both no build and build project scenarios with expected traffic counts in the year 2050. To be clear, the no build scenario is the scenario in which the project is not built and the existing alignment modeled with expected traffic volumes for the year 2050. If residential sound levels are modeled to be above the noise abatement criteria, that area is considered impacted and a barrier analysis will be conducted. The barrier analysis involves modeling each individual residence in a given area and determining if barrier walls are reasonable and feasible according to Illinois Department of Transportation guidelines. If a barrier is considered reasonable and feasible according to these guidelines, the noise analysis will conclude that a noise barrier is recommended. We'll now take this time to open it up to questions for both Cindy and I about noise and other environmental considerations. And we may direct you to another breakout room if we believe your question can be better answered by another team member. So feel free to put some questions in the chat box and we'll be monitoring that and answering them as they come in. Okay, first question looks like, when will the sound study be done? So I believe that will be taking place when the recommended alignment is chosen. So that, and from in between now and the beginning of construction is about 5 to 10 years. So it'd be somewhere in between now and that beginning of construction.
Another question, I think it's two.
Yep. Have you reached any conclusions yet based on your initial work? I wouldn't say conclusions, but we have kind of seen that sound levels, existing sound levels are close to being above the noise abatement criteria that I mentioned before, which means that it's very possible that the project will have a barrier analysis. So we have taken measurements of the existing corridor, and although we don't have any real conclusions yet, we've seen that a lot of these alignments we've given a score of 3, which means minor impact to no impact. So I would say the majority, all but 3 concepts, we've given that rating. So that's about as far of a conclusion as we have come to so far in the noise analysis. What does CNE04 mean? Good question. So CNE means common noise environment, and CNEs are grouped with receptors of similar land use and similar exposure to the roadway. So you can see there CNE01 and CNE04 are blue because they're residential, and residential CNEs are have a specific noise abatement criteria for residences. CNE 03, 07, 05, 06, all the ones in green are a different land use. Those are for offices and dining, and those will have receptors at areas of outdoor use. So something like a picnic table outside of the Starbucks would be an example of a receptor, and things of that sort. And those CNEs have higher noise abatement criteria, which means there must be higher sound levels at those receptors in order to call them impacted. So the kind of follow-up question from Jill says, so you have to meet that initial cut point to complete the expanded study. I think I know what you mean. Feel free to, put another in the chat if I don't answer your question. So the thing that will definitely happen in the sound study will be the existing measurements. So that has already happened. What you do with those existing measurements is you use, while you're taking those measurements, you also take traffic counts. So you're during, let's say, a 10-minute measurement, you'll also say, okay, how many cars are going by during that measurement? You take that data, both the traffic counts and the sound levels, and you input them into the sound model to make sure that the sound model is accurate. So you want to make sure that when you input the traffic counts you observed, you're getting within 3 decibels of the sound level you observed. So that is kind of why you take the measurements, to make sure that your model is accurate. From there, you model the no build case. So you model the no build case, assuming the project does not happen. From there, you would then model the project, and you would compare the no build and the project. The 2 ways that you can get an impacted receptor is if the project is 15 decibels louder than the no build, or the existing condition, or the project does not meet that noise abatement criteria, which for a residence is approaching 66 decibels. Let's say that neither of those 2 things happen, then the study is done. You wouldn't go into the barrier analysis. For this particular case, we do believe that the project will, the residential CNEs, common noise environments, will be impacted. So we will most likely move forward with that barrier analysis. And I think that is what you were wondering about. Great. Answers the first question. Great. Feel free to let us know if you have any more. I think that's all the ones we have now. Okay. Brian asked, would the high dBA need to be constant or just frequent? Okay, good question. So the reason we do kind of the process I described, the existing measurements and then the calibration of the model, is because the observed measurements, you try to take them during free flow conditions. So if you think about rush hour, like a jam-packed road, that's technically not the loudest the road is. The road is the loudest when the traffic is free flowing and there's not as much congestion. So it's able to move, but there's quite a lot of cars on it. So once you've kind of calibrated your model and you think it's accurate for the area you're modeling, you then input the maximum traffic counts into that model, and the model will then output the sound level. So it's not quite a constant sound level, but it's an averaged sound level over, I believe it's an hourly average. So let's say when a truck when a loud semi truck goes by, it goes up to, let's say, 75 decibels or something. That number will not be the number you use for your to say, you know, what the sound levels is from the roadway. That might be a maximum sound level that you observe, but you end up taking an average with over an hour of what that sound level is. So I believe it's not exactly a constant sound level, but it is an average over an hourly time period. Any other questions? Feel free to type them in the chat box. Yeah, unless we don't have any questions, I'll talk a little bit more about what goes into that barrier analysis. So if you do have a receiver that's impacted, you look at a few different things to determine if a barrier is both feasible and reasonable. I'm kind of summarizing what you see on this slide here. So feel free to kind of read along and see if you have any questions. So feasible means that you're getting 5 decibels of reduction at least 2 impacted receivers. So the receivers that got you to this barrier analysis phase, are you getting 5 decibels of reduction with the barrier wall? If you are not getting 5 decibels of reduction at those receivers, the barrier is not feasible. It's not doing a great job as a barrier, and therefore it won't be considered feasible. And then another reason to think about feasibility is building that barrier possible from an engineering standpoint. So topography, is there a very large hill or something that wouldn't allow you to build a barrier? Safety and maintenance and drainage, all those kind of different engineering considerations goes into feasibility. So let's say you pass that phase, you say your barrier is feasible, then you move on to the reasonableness phase. So to be reasonable, there's 3 different things that you should kind of hit on. The first one is to get a noise reduction of 8 decibels as at least one benefited receptor. So you'll hear me talking about benefited receptors versus impacted receptors. Impacted receptors are the receptors that got us to this phase. So the receptors that are were modeled to be 66 decibels or approach 66 decibels from the project model that we developed. So that's an impacted receiver. A benefited receptor, the impacted receptor. A benefited receptor is any receptor that gets 5 decibels of sound reduction from the noise wall. So you can be a benefited receptor without being an impacted receptor. During this barrier analysis, we look at those benefited receptors and we see how many are there, and so that's kind of what we look at for the reasonableness. So the first step would be noise reduction goals 8 dBA for a benefited receptor. Next one is, does the cost per benefited receptor exceed the applicable allowable noise abatement cost? So how many benefited receptors is that barrier benefiting per the size of the barrier? And then finally, it comes down to the viewpoints of the benefited receptors. So there's a kind of a vote that goes out to those that are benefited receptors if they do or do not want that barrier. So if both those feasibility guidelines are followed and those 3 reasonable guidelines are followed, then the noise study kind of concludes with you have a feasible and reasonable barrier. All right, looks like we have. Okay, we have a question asking, so if the numbers are high for CNEO4, meaning the CNEO4 is impacted and a barrier would be considered, so we'd go through our barrier analysis. Would the barrier be a wall similar to those on I-90 already? And would the noise wall be on place, maybe in place of the wooden fence currently in place by the residences. So the type of barrier is dependent. It may be similar to something on I-90. As for in place of the wooden fence, sometimes based on the improvement option that's chosen, that fence might be that might stay, that might go regardless of the barrier wall. Unless that's like a personal, your backyard fence, then it wouldn't, obviously. So the barrier wall would be probably similar to something on I-90. When you model and you kind of go through this iterative process, you determine how tall the barrier is. So that you would not know until you kind of go through this whole process of how tall the wall is. So I hope that answered your question. If not, feel free to type another one. And the wooden fence that's currently there would not do as much attenuation. So it wouldn't help block the sound as much as those barriers on I-90 already would be.